After we gathered all this information, we can do some kind of choice modeling. So we can describe firstly the v vector. It has a constant, and it has travel time, it has travel cost, and for the case of the car, it also has the cash out option. And for the share ride, we have no cash out option, as well as for the other.
So this is car, share ride, the third
Public transport side, and we also had on foot, so 5 alternatives.
Okay.
So I haven't written it here, but we also had on foot.
How many levels did you use for each attribute?
Levels, how many?
You mean yes, the travel costs on the travel?
Yeah, for example. Yeah.
So the travel time is what people told us that they need to come to work.
Okay.
But is this...
We asked them how long do you need to come to work?
Yes, but is
But
this...
they said 10 minutes,
based on
12, 15
RP?
minutes as well.
So
Is it RP?
is it fixed?
This is fixed, yes.
Oh, so you basically did an RP study, reveal preference.
This is combination. This is a combination of reveal to state preference. So the only...
Okay.
Okay,
So
now-
you didn't use an experimental design. I mean,
No, not at all.
So you
Not at
use
all.
the
With G's,
level
we
of the
use the-
attributes is what they told you.
Exactly.
Okay.
So afterwards we set the constant for the car to 0 and estimated this model. I will show you the basic results because the model was much longer, as you can understand. So we divided time in vehicle time for motorized and non-motorized roads, and out of vehicle time, travel cost and parking cash out. This is just for car use, and the job ticket only for public
These are
transport.
results of a multinomial logic
Multinomial logic.
that has been estimated for the whole sample.
For the whole sample, exactly. So what comes out seems to be logical. We find also minor evidence for individual specific variables such as income and so on. And
And alternative specific constants here, it's not.
I haven't put them in there, but they are just logical. We set the constant of the car to 0, and the other ones were negative.
Okay.
For share ride, it was no significance at all. So it seems to be logical. So that's why I don't present. So the other idea is to construct a nonlinear model. So we can do some kind of box-Cox transformation, as for instance does Mandel, Godry, and Rottengatter or Godry.
No, you have already done the data acquisition on this.
Yes.
No, because should this paper come to me as a referee, one critique is how do you account for the hypothetical bias, in the sense that here you are mixing from the interviewee perspective something he knows very well, and they are the costs you are describing, with something he really has never heard of. You know?
Yes. Yes, we do not account for this.
Okay.
Simply just like
Yeah,
this.
okay.
So it's the first.
It's just a,
This is the first. Let's say the first stage of probably also additional.
this is
future
very
paper.
interesting what you're doing. Very interesting.
So we can do also some kind of box-Cox transformation. Box-Cox transformation is widely known and is what Marc Godry since the last 40 years does. What happens in there is just the probability function has now the slope depending on this lambda. And to tell you the truth, I'm not really sure whether this is microeconomically justified. I suppose that if lambda is between 0 and 1, yes, but not if it was not in this range. I don't even know whether, for instance, all these welfare indicators, that's like consumer surplus and so on, do apply when you use this kind of transformation. So it is something that really not really trust really good, you know. So, but still, we estimated, we did this kind of Box-Cox transformation, and we had also some results, seem to be similar, and we also estimated the lambda parameters for Box-Cox parameters for all these variables. What comes out is we have variables between 0 and 1 for all modes, and we have the lambda parameter equal to 0 for the cashed out alternative, which means that we have a logarithm in here.
Yeah.
So the parameter estimates, you know, with the Box-Cox logic model, you fit the data to the model and not the model to the data. This is the problem. So, t-values are becoming lower. And now the problem is, what puzzles me is the goodness of fit of both models. They have very similar goodness of fit, and if you perform the Horowitz test, then you can find no difference. So these both models are equally good, and we tried to find out whether they're logical, at least. So we computed elasticities. This is for the linear model. We find here that the elasticity of demand for cash out and for the travel costs are very, very similar, very close to each other. This would imply that parking policies could have been seen, or cash out policy could have been seen as an alternative to road pricing. On the other hand, if we calculate, if you compute the elasticities for the nonlinear model, then I can find out an isoelastic demand function for cash out and certain elasticity for the travel costs, which now would imply that there are regions where the cash out option performs better, and there are regions where the cash out option performs not that good compared to road pricing. And exactly these results puzzle me, because we don't know which model is better.
One thing I would definitely do, given the structure of your paper, is to see if, and this can be tested, there is a paper by Enscher on this, if there is this phenomenon that is attribute, it's not, I don't remember the exact term in English, but since you are using similar, I don't remember what's the exact word, but since you're using various forms of money, but you give this money different betas, okay? Do actually people keep them separate in their mind so you can attribute one beta each, or do people just consider relevant the net effect? In that case, you would have just one beta and all the other attribute compensation.
Let's take the travel cost minus 0.2 time
Basically, what I'm
or
saying
threshold
is
minus
it that
0.6.
you can create a variable that gives you the overall money effect of this.
All right. This could be something to do in this model. Yes.
This is
Yes.
whenever you have, because as in the case of time, you have different betas, and it's still time.
Yes.
But
yes.
since the pleasantness of driving or waiting is
But
totally different,
I can
they
put all
are,
them together.
they are different goods in a sense.
Yes.
But money is money.
Yes.
So or else you would have to prove, and it's whatever result you get is fine in the sense that if you find that they compensate between the two amounts, what you can say is that that is the relevant variable, and you probably explain, you may be able to solve the box-cox problem you have, or else, if they do not compensate, you get a better model keeping them separate. What you can say is the fact that, in fact, it is relevant how you ask for money. So there is a problem issue of the mean of payment. One thing is to just spend money because you go to gasoline in your car. One thing is to pay additionally,
Yes.
even though the effect is the same.
Yes, because €1 is €1, but you may have different transaction costs. So
Yes, and also perceptions.
Exactly as well.
The fact
Transaction
that,
costs, we
I
haven't
pay-
even talked about it at all. So transaction costs could be the solution. Yes.
And also, I think it's relevant the meaning you attribute to money. It's not just the amount of money you are spending, but the motivation. Now it goes back to the ideas you were mentioning on fairness. At the end of the day, I've spent €10. But did I spend €10 for my gasoline, or did I spend €7 for the gasoline and €3 for parking? Since I believe parking should be free, that costs me more.
All right.
Even if
So-
I'm still spending €10. So whichever result you get is fine for you. You get different explanation of the phenomenon.
Yes.
But this is something that you should be testing.
Yes, certainly. So, and I think more or less this
The more
is
you
it.
talk about this, the more I really like. This is very.
So I think this is it. I present you the two models and the two possible explanations that still, on one hand, we could have parking cash out as an alternative option to road pricing. This is by the result by the linear model, and on the other hand, we can identify some areas within.
You can do many more tests on these nonlinear effects. You can transform the variables, in the sense you have a log transformation. You can, something else I would definitely do, is to create a new variable that gives you the amount, because especially since you are giving a fixed range, which is 1, 5, which is a given range. It's not a percentage range, because what you could do is see how that relates to what they already spending. If I'm spending €100 and you ask me for 5 more,
Yes.
I don't even care
As
about
you
it.
see, the range in the diagram is only from 1 to 5 as well. So we just took this region to show. Yeah. All right.
But what I'm saying is that you can get a new variable that expresses basically the relevance of the cash out compared to the generalized ex-ante total cost.
Yes, this is what is
Another
off
thing,
the
you can do here is to see if there are kinks in, because you are assuming.
Yeah, so you need different little diffractions.
Yes, you have to be, and that goes back to what Valerio was saying at the beginning, because since you are not using, and this could be an improvement if you will go back on the field again, since you are using just RP data, you cannot test if there is non-linear effect in attribute level variation. Suppose next time you develop an experimental design, you put at least 3 levels. At that point, you can discover through the data whether there are kicks, and you usually find this.
Yes.
Piecewise linear.
Piecewise linear.
Exactly. So, I can just recapitulate my results. And elasticities between travel costs and travel times. Travel cost and cash out are very similar for the linear model. Elasticities differ at different charging levels for the non-linear model. And certainly for cash out we have higher acceptability. So higher acceptability implies that the total overall welfare effect, even if cash out derives lower responses, could still be higher due to acceptability
This
issues.
second point I think is very important, but you should elaborate more, because here I think what you are discovering is that there is a status quo effect.
Yes.
So basically, and this is what you would get a big improvement maybe if you develop an experimental design, is to see how far away you are from the status quo reference point. He has written a paper on this. Amanda Satopoulos has written a paper on different mental reference points. Ideal,
This kind of
de facto,
prospect theory.
exactly.
Okay.
Because especially under this respect, I think this is extremely important to consider the status quo you are departing from.
Yes.
It's not a problem of amount.
Yes.
In a sense, this is linked to what I was saying before, that you are interviewing a sample that is very heterogeneous in terms of what they consider normal. So the differential effect is linked to the amount you are proposing in proportion to what they already have in their mind. Since this is very heterogeneous, even if you are proposing the same amount in terms of difference, it has a totally heterogeneous effect due to the status quo they are departing from, in my
Yes.
opinion.
But all these issues are not touched in this experiment. This is just the first stage to start with. So I think
This is very good. I'm not criticizing. This is very good in itself. I think there are different ways you can improve along the different alleys, research alleys.
You can try different reference points as I was saying. So the status quo and the ideal. Yes.
Even in terms of the reference point are, I mean, since Scarpa proved it, whenever you put, there is an inertia in human behavior,
exactly. So,
generally speaking.
yes.
But the inertia may be different for different people. This is also what we discover in the airport, regional airport.
So, thank you very much.
But we didn't,
Thank you for this discussion.
We didn't say anything about why the two models look different, and so why in the linear model we end up with this kind of elasticities, and with the non-linear one, totally different.
That is exactly when I had to go outside for research, so I didn't get that part.
So maybe, no, we will say anything, but maybe we can go here.
So, what theory says for these lambda parameters, if they are 1,
Yeah,
then I have the linear model.
Yeah, that
So,
was
if it's 0, I have the log model.
yeah, that was
And-
thinking.
And we see that for travel time and travel costs, we're very close to 1.
Yeah, that
So we have a linear, almost a linear travel time and travel costs
Effect.
effect. So, and we have a log effect for the caching out option. So this would be the reason.
That's the reason why the two models are quite,
but they
very
still
similar
perform
in terms
equally,
of
you know.
adjusting those square.
Because maybe you are, whichever you are choosing, especially since Christos is using a multinomial logic, you are averaging the effects of both, so you end up having, if you go linear for everything, you do not consider the nonlinear parking cache-out effect. If you go nonlinear for all the attributes, you lose the fact that 4 out of 5 are linear. Well, have you tried
The mix.
you should.
Yeah.
Why don't you try this? Why don't you create the log of the parking cache-out only
and
estimate the model linear?
So let's
So
see
you
whether it
catch-
improves or not. So
You catch the
This
non-linearity
would be
for
also-
the
yes.
parking cache through variable transformation.
Yes.
But since what we here looking at this, we discovered that the model is 85% linear. We keep it linear, but accommodate the non-linearity through a variable transformation inside the linear model.
still possible.
And this is, you can do this in 5 minutes.
Yes. Not much effort.
And maybe this
will help the model to improve. Yes.
Or maybe also other models like modal and class, for example.
I will not have additional information on people in this.
No, but you can look at a Latin class given the sample you have. Basically, because here you are averaging many things. You are making it very, still very interesting. Have you written the paper?
No, we are about to write it.
And then you send us and we publish it at the CREI paper.
So thank you very much for your attention, and
Thank you.
we have